In our previous video, we did discuss about how to insert the record in binary search tree as well as we saw the functionality of display. Here, we will try to understand like if we have to calculate the size of the binary search tree, then how we can find. For example, currently we are adding this many node, right? Like 1, 2, 3, 4, and 56 is the root node. So we should have 5. So what we can do, like basically while inserting the record, basically at this point of time this line records are getting added in the left tree, and here it is getting a right tree. So just make it left count plus plus and right, that is we have one variable called left count and another one is right count. This variable basically will be counting. So, how many variables, how many nodes are there in the left count in the left side of the root node, and how many are there in the right side of the root node? And then finally, left count plus right count and plus one. So, this one will be for the top root node. Okay. So, left count, if you see 1, 2, 3, we have three node in the right side, and ignoring these many roots. Okay. So, we will ignore this, and this. So officially here we have 3 in the left side and 1 in the right side. So 3 plus 1 4 and 1 is a root node. So this way basically we calculate the size of a binary tree. Okay. So we will have here a total 5, and that 5 basically it will be showing. One more thing that needs to be keep in mind is, here you will see the importance of a static keyword. Like if you are not making a static, what will happen? It will start behaving like instance variable, and you will get the wrong, because this left count now will be belonging to every individual object. However, if you make it a static, okay, when you make it as a static, then it will be common to the entire object. Now this is not the specific to any object, this will be common to entire object, because a static variable gets allocated only once in memory. However, non-static variable will be keep allotting as much as create you will object you will create, that many times those variables in non-static variables will be created in every individual object. But in a static this will be common, so left count will keep increasing, and when right node will be added, right count will be increasing. So this is how basically will be counted. And now if I show you the gate size, so it should give us basically the 5. Okay, so let's see the output. And here it is saying size of the tree is 5. Basically we have 5 node in the root. So this way you will be able to find, just a straightforward guys, just make a variable and which will keep increasing in the right side, okay, as well as left side, and this you need to put in the insert method. Okay, so this we have insert, and you just keep these variables and you will be able to find. Also, let's see how basically if exist method will work. For example, we have here, boolean. Let's make it as console right line here, if exist, and we will uncomment this line. Maybe let's see 29. So we will check for 29. Okay, now I will put breakpoint directly here, and we will try to trace the if exist method. So simply I will run it, and let's go, and we are passing the binary search as well as 29. Here I will say F11. Here element that we need to search is 29, and this is the entire record that we have, okay, where root node is 56. Okay, now we will say node equal to null. So check node is null. No, node currently is not null. So if it is null means record is empty, but here node is not null, so if will be false. Now node dot node data dot equals element, it will start checking. And here if you see in node what we passed, we are passing binary search, means binary search is quantity pointed to this a object. So this a object is getting passed to this method called node. So in that node means a object of node data which is 56, and then we are checking equals element 29. So are they same? No, they are not same, right? So it condition became false, control came into else block, and here it will print the current element is, this is the placeholder where node data will be printed, that is 56 in BST, and then it will check the another if, means element dot compare to, and compare to method we already know. Here compare to will be comparing. So if the instance variable will be greater, then it will return +1. If it is a smaller, it will return -1, and both instance as well as values both will be equal, then it will return 0. So element we have is 29 which we want to find, and node data is 56, right? So element is smaller, right? This instance is smaller, so it will return -1. So this evaluated to -1. -1 is less than 0. Condition became true. So it will execute if block, and then again this is a recursion call. So if exist method is getting called with search element 29, and now see what we are searching, node dot left tree. This is how actually it works in binary search tree. We go and check, and if number is smaller, here you see key element is 29 and root node is 56, so search element is a smaller, then we should go towards the left side of the tree. So we are passing the left address now, means node dot left tree, that is node is nothing but binary search only, that is this here. So binary search means a object. Okay, here how you can see कि देखो, we pass the address of binary search, means whatever the binary search we are passing from here, that is nothing but in binary search we have the value of 1000, assume. So same address will be copied inside node also. Okay, here this node. So if I tell you one more local variable will be created called node, and they also have exactly same address, and this one will also be pointing to a object. Okay, and now you will be able to understand कि node dot left tree, since node is also pointing to a object only, so a left tree of a object, that is 2000, right? So 2000 we are passing from here with element, so element is 29. Now again this exist method will work, and remember this time what will be the value inside node. So from here we passed the 2000, so this 2000 will copied inside this local variable node. Okay, so now this node means one more time in recursion will be executing, and now if you know one more basically node will be created here, I can say, and will start pointing to 2000, this one. Okay, so here this one will be pointing to b object. Okay, and this node basically is pointing to b object, then again node is equal to null. No, node is not equal to null, so here control will go to here, node dot data. So node dot data currently is 31 and element is 29, so are they equal? No, they are not equal. So here we'll say current element is node dot data which is 31, then if element which is 29 and node data is 31. Okay, so 29 is a smaller, instance is a smaller, this is instance and this is called value. Okay, so instance is a smaller, so compare to will return -1. So this expression will evaluate to -1. -1 is lesser than 0, yes, condition became true. Again if exist will work with element 29, and node dot left tree means currently node is pointing to b object. Okay, and left tree of b object is 4000. One more time this method is getting called, and this time address we are passing is 4000. Okay, so element will remain 29 only, but this time this node will have a value 4000. Okay, so here one another node will be created with address 4000, and here it will be pointing to d object. Okay, d object. Now control again will go there and will say node is equal to null. So if you see basically node is not equal to null because it has the 4000 address currently. So it will escape, then will go node dot node data. Node is pointing to d object and node data of d object is equal to 29, right? So 29 equal to 29 condition became true. Agree? So it will go inside this, it will say yes, found the element in BST this data 29, and it will set result is true because we successfully found the element which we wanted to search. Okay, and then we will come out of that, else block will not execute. And then here we are executing element which is 29 and data is 29, so both are actually same. If both are same, it will return 0. Okay, so 0 is less than equal less than 0, condition became false. This condition will be checked key element and node data both are same, so still compared to will return 0. 0 is greater than 0, condition became false. Then it will go to return result, so result is true, and this is an indication. So if it is true, indicates कि successfully we were able to found the result. Okay, so it will return, it will come back to our previous call. If you remember कि three times basically it was executed in recursion, so it will keep executing like that, and finally it will return the result which is true. And now in console it will print true. Okay, so this way basically it works. And if you check, it also showing the iteration like 56 was present, 31 was present, and found the element in BST that is 29. After successfully finding, we are printing this true from here. Okay, so this is how you can write the if exist, or to search the element as well as to get the size. Likewise, we have discussed here insert method, display, get size, and if exist. Along with that, if you have any other a method implementation or any other functionality you want in your binary search tree, you can implement as per your requirement, and you can write your